We now move on to the post-processing steps using our predictions along with IM and IM zeros as inputs. Remember, IM is the letterboxed image, a float 32 PyTorch tensor with shape 1 by 3 by 480 by 640, normalized to values between 0 and 1. Meanwhile, IM zeros is the original image, an 8-bit unsigned NumPy array with shape 768 by 1024 by 3. Its pixel values range from 0 to 255, preserving the original size and format. Inside predict.py, we pass preds along with additional inputs to the non-max suppression function inside ops.py. Once inside, you can see on the left the specific argument values we provided as input, such as the confidence threshold, the IOU threshold, and more. We will cover and explain each of these further as we use them, making their roles clearer. We import Torch Vision and assert that the confidence and IOU thresholds are within a valid range between 0 and 1. Our preds tuple was passed into this function under the variable name prediction, but at this step, we override it to contain only y from the tuple yx, as y holds our actual predictions. Since classes is set to none, we step over that part. Next, we analyze the shape of our prediction, which is 1 by 84 by 6300. From this, we extract batch size, 1, number of classes, 80, number of masks, 0. This is used for segmentation tasks, so we won't be using this, and mask index, 84, also related to segmentation. This line extracts the class scores from prediction, specifically from index 4 to 84. It then finds the highest class confidence score for each grid cell prediction using Emax1, selecting the maximum value across all 80 class scores. If this maximum score exceeds the confidence threshold of 0.25, the prediction is considered valid. We can also run this line in our Colab. First, we download our prediction tensor and load it, as we will use it throughout this section. The result is a Boolean mask, XC, identifying which predictions have at least one class confidence score above the threshold. Therefore, its shape is 1 by 6300. As a side note, a confidence threshold of 0.25 is relatively low and may lead to false positives. In practice, a higher value is often used, but here we are using the default. Next, we create a time limit that is proportionate to the batch size and set the multi-label flag to false. Afterward, we transpose the 1 and 2 indices, preparing our predictions for the next steps. Since the rotated flag is false and in place is true, we proceed with this function. This function converts bounding box coordinates from the XY width height format to the XY format. It does this by computing the half width and half height, and then, using the center position, calculates the corners. In the output, the first two values correspond to the top left corner and the last two to the bottom right corner. Next, we capture the current time in seconds and store it in t. Then, we create an empty tensor with the specified shape, which we will later use to accumulate the results. In the next step, we loop through each image in the prediction tensor. The code iterates over each image's predictions and applies a confidence threshold mask, XCXI, to filter out low confidence predictions. In our Colab, you can see that the shape of 10 by 84 indicates that out of the 6,300 predictions, only 10 predictions remain after applying the confidence threshold. Next, we step over these, and also these, since we have predictions. Then we split our X predictions tensor into box and classes, as we're not using the mask variable here. Since the multi-label flag is set to false, we skip over the corresponding logic. This line of code finds the maximum class score for each prediction in the class tensor and returns two tensors. Conf, which contains the maximum confidence score for each prediction across all 80 classes, and J, which contains the class index corresponding to that maximum confidence score. Next, this line concatenates the bounding box coordinates, confidence scores, and class indices converted to float into a single tensor. It then filters out predictions with confidence scores below the threshold, keeping only those that meet the required confidence level. We can visualize these steps and the corresponding shapes and output values in our Colab notebook for a deeper understanding. Again, for each of the 10 predictions that had a class confidence above the threshold, we have 6 values: the bounding box coordinates, top left and bottom right in absolute terms, the maximum class score, and the associated class label. And by the way, among all the predictions with bounding boxes so close to each other, keep an eye on this one in particular. It has the highest confidence score and corresponds to index 2 in this tensor. If everything goes as expected, NMS, as we'll see shortly, will return index 2 as the final prediction for the car. Next, we step over this since our class's variable is set to none. If a specific class were provided, this line would filter the predictions, keeping only those where the predicted class matches the given index. Otherwise, all predictions are retained. Then we extract the number of boxes, which is 10, and store it in n. If n were 0, the code would skip further processing for this image. In our case, we proceed and also skip the next check as we don't exceed the maximum limit of predictions. If we had excess boxes, they would be sorted by confidence, and only the top ones up to the max limit would be kept. In this case, the limit is set to 30,000, which is quite high,